We're going to analyze the LeetCode hard problem. The problem number is 1012. It's called numbers with repeated digits. The main idea of this problem is that given an integer n, we will need to calculate how many numbers are with at least one repeated digit. So for example, 11, it has one repeated twice. And for example, 100, it has 0 repeated twice, etc. So in order to do this, we first notice that the number of the numbers with at least one repeated digit is actually equal to the total number minus the count for all the digits do not have any repeated value. No repeated digit. We'll first notice this. So our goal is actually to calculate this number. Then we subtract this number from n, then we get the final result. So that is our goal. Now let's use some examples to analyze. For example, suppose n equals to 3, 5, 6, 3, 4, 5, 6, 7. Then in order to do this, we first see the first digit, and it is 3. So one way to choose first digit is 3. So one possible way is to choose 1 or 2, right? In this case, all the numbers after the first digit can be choose. You can choose any number you want, so as long as there's no repeated value. So for the next one we have 9 choices. Then for the next one we have 8 choices. So there are total 4 positions. So it's 9 times 8 times 7 times 6. We call this one is just P94, right? This is P94. This is the total number minus how many number we have already chosen, and put it onto how many positions we have. It's 4. Okay, and another way for the first position is to choose 3, right? If we choose 3, then we cannot choose any number we want for the next 4 elements. So we need to go to next position. What is next position? Next position is 4. Okay, so now we can choose 0 to 3 and choose anything we want. Now it's 10 times 2, 10 minus 2 and 3, P83. And or we can choose 4. And if we choose 4, we will go to next position. We do this repeatedly, which is 5, right? And for next position 5, we still have 2 choices. One is to choose something between 0 and 4. In this case, it will be P10 minus 3, and we have 2 slots left. And we can also choose 5 here. But if we choose 5, we go to next position, which is 6. And we continue this process to get the final answer. And remember, this whole thing is for if we want the digit number is 5, so we need the length is the same as n. So if we say the length is less than n, then we can choose any number we want. Okay, so now let's first define this function to calculate P9, 4, etc. So this is P, we say x, y. This function is just to do the multiplication y times. And for each time, we decrease x by 1. Then we return our ES. Okay, and we define the count as this number, and so when we return, we just return n minus count. Then first we add. We say if n is has the size of 5. First we calculate if we want some choices for size 1 or 2 or 3 or 4. Okay, so for these we are quite freely to choose anything we want. So we suppose S is just a string representation of n. Then for each one of these, we can, for the first digit, we can choose from 1 to 9, right? And for the second, from the second, we still have 9 numbers left. So because we have 1 number chosen, and in total we have 10. So we have 9 numbers left. And we have, how many slots left? It's, we have I minus 1 slots left, okay? So this is the total way of choice for if our digit size is I. And for each case, we add it into count. Then we go to the next step. Next step is, suppose we want to analyze if the size is equal to the size of n, how to make the choices. The first thing is, for the first digit, because it cannot choose 0, so we calculate it separately. So for the first digit, how many ways can we choose? The first digit is just this number, right? We can choose from I to the 1 less than this digit. So we have this many choices. Then we have in total 10 numbers, and we have used 1 as the first digit. And how many digits we have? We have S size minus 1 slots left. So initially we have this number. And we also need something to remember which digit we have used. So we define this vector. The vector is just 10 digits. So now the first digit has been used. We say it's S minus 0 is true, right? Then we go to the loop from the next position and all the way to the end. And for each position, we first calculate what's the value for this position. For example, if I equals 1, then x should be equal to 4. And if I equals to 3, x should be equal to 5. Okay, this is x. And then for each number less than x, that's our potential choices. And of course, we need to choose where the position is not being used. So if stj is false, we can do the following things. Otherwise, we just continue. Then for this position, we have already chosen. And from the next one, we have in total 10 digits. And same thing here. We have from 0 to I, we have I plus 1 digits already used. So we minus I plus 1 here. And how many positions are left? We have from I plus 1 and all the way until n minus 1. This is n minus 1 minus I plus 1 plus 1. This is n minus I minus 1. Okay, so these I think we cannot use n here because n was used for already used. So this is just as size, right? So this is as size minus 1 minus I. Okay, so we put it here, so minus 1 minus I. So this many positions are left. Okay, then we say if stx is being used, so we are done here. For this line, I'll explain. For this line, it's for situation like 3, 4, 5, 6, 7, and if this position is not 5 but 3 again, then we know that we cannot repeatedly choose 3, so all the way down we can just skip. So for this position we only need to consider 0, 1, 2, so there's no need to continue, so we just return. Okay, then after that we mark x as true. Remember that at the end we still have one choice left, so we add it back to count and we return n minus count. Okay, now let's see if this will work. I think this should be n. Okay. Okay, it's accepted. Yeah, then we have solved this problem. Yep. Thank you very much and see you next time.